Alright, so this is the AVS, the Autonomous Ventilation System. And within the AVS we have components that are making this ventilation system completely autonomous and operate automatically. First we're going to start off with our motion detection system, and this will pretty much determine whether the room is occupied or not based off of movement from the people within the room. Then we're going to have our override switch, which can override the whole automatic system. So you could have an on or an open state, a closed state, and then a state that completely runs off of your processor. So then if you come around here, within our package here, we're going to have our transceiver antenna. This red LED determines whether the heater is on or off. This green LED determines whether the air conditioner is on or off. Within this package we have our ARM processor, our transceiver, our temperature sensor, and our power supply. So then if you can get that in back there through the stand, we have our servo which will open and close the ventilation system. So now we're going to demonstrate our override switch. If you come in a little bit closer, you'll see that the vent right now is currently closed. If we switch this switch down, it's going to go into the on position, or the open position. And what this pretty much means is no matter what's going on, your ventilation system is constantly going to stay open, just like your normal vent does in your home right now. If we switch it all the way up, your ventilation system is going to close. So no matter what happens, this vent's always going to be closed. If we go to the middle position now we're currently running on an automatic system, and based off of what the processor is telling you, that's what it's going to dictate whether the vent opens or closes. So now we're going to go ahead and demonstrate a motion detection system. And with our motion detection system, it's gonna interrupt every time it senses motion. And after it senses motion, it's gonna pull every minute after that to see if the room is still occupied. And the reason that this is important is because when the master asks for the slave the status of the room, the slave can then relate to the master the occupancy of the room. So if motion has been detected, it can then tell the master processor that the room is in fact occupied. And if there's no motion detected, then it can relate to the master that there's no occupancy within the room. So to go ahead and show that the motion detection system is working, go ahead and come in closer, and you can see that right now there's no motion detected. But if you go ahead and see me wave my hand in front of the motion detection device, it immediately interrupts, and then after a minute it's going to check again to see if this room is occupied or not. And that pretty much sums up this whole motion detection system. So right now we're going to go ahead and demo our temperature sensor. Our temperature sensor is pretty much going to take the temperature of a room when motion is detected, when the override switch is changed, when the vent opens and closes, and when the master requests a status update from the slave. Currently, right now, you can come in and see that our temperature is being sensed at 87 degrees. What you just missed right now is it sensed it again at 87 degrees. And within a few more seconds, because for the demonstration purposes we're polling every 10 seconds, it's going to tell us again that the temperature is in fact another 87 degrees. And that pretty much is going to demo our temperature sensor. So now we're going to go ahead and demonstrate this ventilation system operating based off of RF transmission. We're going to have Kevin over there that's going to be controlling the master processor, and what he's going to do is he's going to send a status to the vent, whether it's going to be open or closed, and whether the air conditioner or heater is operating. So Kevin? So right now, we got a transmission from Kevin saying the heater is going to be operating, and because ideal temperatures are not met, our ventilation system is currently open. Right now the heater is still on, but for this particular room, the ideal temperatures have been met, so therefore the ventilation system has been closed, but the heater is running based off of other rooms that are requiring heat. So right now, we're cycling through our third stage, which is going to have the air conditioner operating while the vent system is open. So again, just as we saw before, our air conditioner is still operating. However, because of the conditions of this room and the specified details of the user, we know that the temperature has been reached to ideal temperatures, but other rooms are demanding for a colder air. So the air conditioner will continue to operate, but this room will have its ventilation system closed. So then if we walk over this way, we have our master processor, and then for the sake of presentation, we unpackage this, that way you know what's going on within the package. Just as before, we're going to have our power supply and our transceiver, and within this specific one we don't necessarily have the antenna showing, and so So then within this master processor we do have less components, just because there's more internal stuff going on within the software. And then just as before with the package before, this red LED will let you know if your heater's on, and this green LED will let you know if your air conditioner's on. And if none are on, that means your whole system is not operating. So right now we're going to go ahead and demonstrate our communication between our master and our slave processors. Pretty much what happens is when the master is going to request a status update from the slave, this is what's going to be sent over. Excuse me. So if you go in and zoom into the screen, you'll see that our vent ID is at 50, and then our temperature is currently at 87 degrees. Our vent status is open. The override switch is on auto, and our room is currently being sensed as an occupied state. So then if we show, if the master processor now is requesting the information, that information will be sent over to the master as it's been requested. As you can see, our vent ID is 50, our temperature is 87, our vent status is open, the override switch is on auto, and our room is currently being sensed as occupied. So that's pretty much the exact information that we saw on our slave processor being relayed through RF communication to our master. This has been a demonstration of the autonomous ventilation system, and on behalf of Kevin, Cory, and Eric, we'd like to thank you for watching.